Hey guys, what's happening people? Welcome to today's session. I hope a lot of you guys are doing good and taking care of yourself as always. This is Anoop, your Master Teacher of Science here at Vedantu, and a very warm welcome to all of you guys out there. And today people, today is a special day. You know why? Because we're going to study something super duper interesting. One of my favorite concepts when it comes to sound, and that, my friends, is nothing but what is the difference between natural, forced and damped vibrations. A very interesting topic. I'm going to try my best to show it to you guys in the most experimental way possible. I've made some jugards over here, so we'll try to explain that. So stay till the end and understand what are the concepts that I'm going to teach you today. And if you have any doubts, let me know in the comment section below. Don't forget to subscribe to the channel as well, and also hit the like button. Alright, so people, today, like I told you, we'll be studying about natural, forced and damped vibrations. A very important topic, especially when it comes to your, when it comes to your board exams. There are a lot of questions being asked in the past as well from this chapter. So let's understand what exactly this is. So without wasting any more time, let's get into it, people. So before we get started, this is the motivation for today. The quote is this: focus on the destination, not the difficulties. Exactly like the quote in the previous session. Do not focus on the obstacles, focus on the final goal. Because everyone can complain about the difficulties, but the people who focus on the destination, on the goal and work for it, they are the ones who are going to get to success. And you're going to be just sitting there and complaining about how difficult it was, or whether or not you could have done a lot better. Rather than having regrets, people, give your best shot and make it a point to push yourself forward. Right? So that's it, guys. Let's get into today's topic. Again, we have done sound waves, reflection of sound waves and echoes, and today people, forced are natural and damped vibration is what we're going to talk about. But as always, guys, I had given you homework in the last session of sound that was basically from echo. The question was this: the minimum distance between the source and the reflector in air to hear the echo is approximately how many meters? And the answer to that question, it's approximately 17 meters. So you have to be at least at a distance of 17 meters so that you are able to hear the echo. Only then the sound waves can basically reflect and you hear it twice. Otherwise it'll just be superimposed and you hear it as well, right? So that is the answer, people. Congratulations to all those guys who gave the right answer. Keep up the good work. Now it's a very important question again, because echo is something that you're going to be you can expect a lot of problems from that chapter. So from this chapter, especially coming from echoes, so make sure that you pay attention, or if you haven't watched the video already, make sure that you go and watch that as well. So let's get into it. Natural, forced and damped vibration. Let's start with the natural vibration. Okay, imagine that I have a pendulum. Dun, 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 dun. Yeah, this is my pendulum. It's my earphones. I don't have anything else to make a pendulum out of. So, pendulum, string, pendulum, stuck to a rigid surface. Alright, now, this pendulum, if I just apply some force to it, what would happen? It'll start to oscillate, right? It'll start to oscillate. It means that it'll have its own frequency. Basically, when it starts to oscillate, it'll have its own frequency. Now, the thing about this pendulum is this: if I push this pendulum for now, let me just push this a little. What will happen? It'll start to oscillate. It'll start to vibrate with its own frequency. Everything goes good. Now, if you look at it carefully, after some time, this pendulum basically stops. Like if you see that, after some time, it basically comes to a state of rest. Now, think about it, guys. What is the reason that it happens? What is the reason that this happens? If you ask me, I would say that there's air particles around that pendulum, and because of the friction, because of the air resistance, what happens is that the energy from that pendulum is slowly lost, and finally it comes to a state of rest. Okay, awesome. Let's say that I take this pendulum into vacuum now, alright, into space, like let's say the International Space Station or something like that. Now, over there, if I start to oscillate this pendulum, you see that the pendulum will continue to oscillate forever. You know why? Because according to what we have learned in the past, in vacuum, there is nothing, there's no air particles, there's no water particles, there's no solid particles. So what will happen? There's nothing to provide that friction. So it will continue to oscillate. You know inertia, right? A body continues to be in the state of rest or in the state of motion until and unless an external force is applied on it. You already know that. First law of Newton. We have already seen that. So this will continue to oscillate forever at its what? At its natural frequency, at its natural oscillation, at its natural amplitude. It will continue to do so forever. This is what is called as natural vibration. That is a body that is vibrating without the influence of any other force. Now, if you think about it, people, there is one force acting on it, even if there is no frictional force acting on it. Can you guys let me know in the chat box or in the comment section below what exactly is that force? Think about it. It is not frictional force because it's in vacuum right now. I'm in space, so there's no frictional force. But there is some sort of force that is acting on this one. And that force, my friends, is called as the restoring force. Now, what is this restoring force? Is nothing but, see guys, this pendulum, when I push it to its extreme position and it starts to oscillate, it tries to come to its mean position. That is what it tries to do. It tries to come to its mean position. So that force that is trying to bring it to its mean position, that is trying to restore the imbalance in force, that force is what is called as restoring force. Now, it's the same case, like for example, if you talk about a rubber band or anything that is elastic in nature, when you pull it, it tries to restore itself. You pull a rubber band, it will expand, and then when you leave it, it will try to restore to its original shape. So that force that tries to bring it back to its original shape is what is called as restoring force. And natural vibration, because that is not something that you have in your 11th, in your 10th grade ICSE board. That is why I'm just mentioning this. But yes, if you ignore that force, guys, the force, or basically a natural vibration is nothing but a vibration of a body, a periodic vibration of a body without any application of external force. There's no way. See, you just pushed it once, right? You just put it to its extreme position once and it started to oscillate. You did not do anything else. That is what is called as natural vibration, because you're not doing anything else. You just do it once and it continues to oscillate forever at its natural frequency. That is what is called as natural vibration, because it is doing it automatically without any sort of external force applied on it. So the best thing, guys, again, like I told you, a simple pendulum in a vacuum where the air resistance is zero is one of the best examples for that. All right, now the thing about this is that, people, the time period of this vibration or this the time period of oscillation, everything is the natural time period of the body. It is not that it's not that you get to decide it. It all depends on the body. What is the size of the body? What is the shape of the body? That is what it depends on. Not on you or not on any other external factors. It depends on the body itself and the frequency, natural frequency of the body. And more importantly is, if you think about it, if I talk about in vacuum, if it starts to oscillate, what about the amplitude? The maximum displacement of this thing would be the same every single time, because there is no external force. So it will continue to vibrate like that itself at its natural frequency. So if you were to represent that in the form of a graph, I'll show you that in a minute, because that is also a very important aspect. They will be asking you questions like, draw a graph of natural vibration, displacement versus time graph for natural, damped, as well as forced vibration as well. So we'll look into that in a minute. But before we get into that, guys, let me tell you one example of natural vibration. The best example is nothing but a pendulum. It's a simple pendulum which is displaced from its mean position and start to oscillate. This is one of the best examples of natural vibration. But yes, guys, different bodies have different natural vibration. It is not just a pendulum, but different bodies have different natural vibrations. Now, if you want to express it, if you want to express the value, or how do you find out the natural frequency of a simple pendulum, this is the formula to do so. But you know what? Don't worry, guys. There will not be any questions asked or based on this. There will be no numericals based on this. You just need to learn this. You However, you have to remember this. It's not like you can just ignore this. You have to remember it, but not for the sake of problems, but there'll be a lot of word problems asked on this type. For example, they'll ask you what is the relationship between, if you talk about a if you have a pendulum, what is the natural frequency, or what is the relationship between natural frequency and the length of the pendulum? Something like that. These are the kind of questions that you can expect over here. So what is the formula? Frequency is equal to 1 by 2 pi root of G by L, where G is nothing but the acceleration to gravity and L is nothing but the length of the pendulum. And more importantly, guys, remember this one thing without fail. F, that is frequency, is indirectly proportional to the length. So if you increase the length, the frequency would decrease. If you decrease the length, the frequency would increase. This is the one type of question that you can expect from this. Now we'll be looking at this kind of the formulas of of natural frequency of a string and even for a spring as well. But then again, all of these are word type problems. They'll be asking questions like what is the relationship with this and this. So don't worry too much about it, but still remember it. It's very important to remember it. But nonetheless, there'll be no problems as well. So don't worry too much about the formula per se. It's just that. Alright. So G is acceleration to gravity. L is nothing but the length of the pendulum, and the relationship between frequency and the length of the pendulum is it's indirectly proportional. And that's it, people. Moving on to the next one. What about a spring? Not a string, a spring. If you were to put a load on a spring, suspend a load on a spring, what is the type of natural, how do you calculate the natural vibration over there? Now the formula for that is this people, F is equal to 1 by 2 pi, again 1 by 2 pi itself, but here it will be K by M. What is this K by M? K is nothing but something called as a spring constant. Now, once again, you don't need to remember it. You don't need to know what is a spring constant and all that. It does not matter. But for your understanding, let me just tell you this. Spring constant is nothing but it tells you how stiff the spring is. For example, some springs you have seen, it's more easier to crush. For example, if I talk about a pen, a spring inside a pen, there's a spring inside this, right? So what happens when you press it? It's more easier. But on the other hand, there are other springs you've seen in the past which is more stiffer. It requires a lot of force to compress. Or to expand. That is what spring constant tells us. And more importantly, once again, instead of length here, the relationship is between the frequency and the mass of the load. Because greater the mass, the lesser the frequency is going to be. Think about it. If you have more mass over here, let's think about it. Instead of this one, if I had a bigger mass, the amount of the frequency would have been much more lesser compared to a mass which is far lesser. So frequency is indirectly proportional to mass. So if mass increases, frequency decreases. If mass decreases, then the frequency is going to increase. So that is the only relationship that you have to remember. Again, guys, if you talk about a spring, again, in a perfect world, in vacuum I'm talking about, because out there, on the surface of the earth, because of friction and everything, there is some sort of loss happening. But when you're talking about without any other force acting, this is what is going to happen. Again, you can talk about the spring that is kept in vacuum. Alright. Now the third thing that we're going to talk about is a tuning fork. Sorry guys, about a tuning fork. Now in a tuning fork also, it has its own natural frequency. If you take a tuning fork and hit it on a rubber, and it'll start to oscillate, it'll start to oscillate with its own, or vibrate with its own frequency. And here also, people, it has its own natural frequency, it has its own natural way of vibrating. You've probably seen there are different shapes and sizes in tuning fork as well, and each of these would have its own frequency. Each of these would oscillate in a different way. The same goes with a lot of musical instruments as well, from the flute, because in a flute you have air particles inside. There's an air column inside of it, and that air column also starts to vibrate with its own natural frequency. You just blow it, but then it's the natural frequency of the air that it vibrates with, and that is what produces a sound. And here also the relationship is F is indirectly proportional to length. So greater the length, lesser would be the frequency. Lesser the length, the greater would be the frequency. Right? And this goes with a lot of musical instruments, from sitar to guitar to tabla to harmonica, a lot of string instruments, a lot of instruments that works on membrane, drums and everything. All of these vibrate at a natural frequency. So if you're a musician, This is something that you must know, people. It all vibrate at its own natural frequency. It's not something that you can control. It's just that you apply the force and it starts to vibrate at its own natural frequency, right? Now, if you talk about a string, like for example, a guitar or something, I do have a guitar with me right now. I just stole my guitar from my brother, but then I don't know if it's the right thing to show, but yeah, people, I'm going to do it anyways. So if you talk about a guitar like this, it's a broken guitar. Not it's broken, then it's pretty old. So if you look at the string, people, it's all of different sizes. You see this? This is a little thicker and gets thinner and thinner and thinner. And you see that the sound produces a little different. Just listen. I'm a very bad musician, but you can hear the sound, right? So it's all different. Now, why is that different? Because the natural frequency of the string depends on not just one factor, not just two factors, but on several factors. If you just look at the formula, this is what it's going to tell you. This is one of the most important formulas, guys, because there are a lot of things that you remember. Now, all this while we talked about the frequency indirectly proportional length for in the case of a pendulum. In the case of a string, it was the mass. But in the case of a string, there's a lot of things that it depends on. So the formula is this. F is equal to 1 by 2L, not 2 pi, 2L. So length of the string is something it depends on. It depends on the square root of the tension of the string divided by the pi r square t. That is nothing but the density. With D is nothing but density. R is nothing but the radius. So radius, we have already seen, some strings are thicker, some strings are thinner. So it depends on that as well. It also depends on the length. That's why you've probably seen some people, they're tuning the guitar and all that. They rotate that thing that is there at the end and make it more, they increase the tension of the string. So all of these factors are something that the natural frequency of a string is dependent on. So if you were to ask, if they were asking you, or if they had asked you this question in your exams, think about this, guys. Remember this. Again, you have to remember the formula. The reason why you have to remember the formula is not for the problems, but for the relationship type questions, like what is the type of relationship that frequency has with the length and density and all that. It's not that type of relationship, but you get the point, right? So how is it? Frequency is indirectly proportional to the length. So if you increase the length, lesser would be the if you increase the length, lesser would be the frequency. If you decrease the length, greater would be the frequency. That is the first factor. Frequency also depends on, frequency is directly proportional to tension. That is, if you increase the tension, the greater would be the frequency. That's why you hear a sharper sound when you tighten up the string a little. And the case of radius, frequency is indirectly proportional to the square of the radius. So again, if you increase the radius, again it will decrease 4 times. If you double it, this will become 4 times lesser. So it all depends on that as well. And apart from that, it also depends on frequency is indirectly proportional to the density of the material as well. So the kind of material that you use, the density of that material is also a factor that it depends on, right? I've done a lot of jigard today, people. Do not forget to hit the like button and also to subscribe to the channel as well. Alright, so now, like I was telling you guys, this is one of the most important things that is very much common in your board exams. How do you find out the natural frequency? If you have to show it in the form of a graph, a displacement time graph, how would it look like? Like I told you guys, if you take a simple pendulum, again the amplitude of this is going to be the same because there is no external force acting on it. It will continue to oscillate with the same amplitude. What is the maximum displacement? What is amplitude? The maximum displacement. Don't forget that. So that is going to remain same because there is no external force acting on it. So if you show the graph, this is what the graph would look like. This is displacement and this is time. So the graph would basically look like this because the amplitude of the graph would be the exact same. There will be no change at all because of the fact that there is no other external force acting on it. And that is what it is. So negative, positive, negative, positive, that is the displacement of the wave. So you can see that it's going to remain the same forever. And the amplitude and frequency of the vibrations remains the same because there is no external force acting on it. And by that, people, we have understood what is the natural vibration or natural, what is the type of natural vibration that you have in different types of bodies. Now, if you've understood this much, the next two things, that is damped and force, is going to be super easy. It's going to be a laddu walk for you people if you understand. That is why I took so much time in understanding, making you guys understand this, because the next two topics is going to be damn easy. Stay till the end so you understand what is the rest of the class. So it's damped vibration. Now, let's say that if I take this pendulum and come back to the Earth's surface, all this while I was in space, now I come back to the Earth's surface. Alright, I'm in Bangalore now. Now, if I start to oscillate this, what would happen? You see that it's slowly decreasing. It's slowly starting to decrease. It is not remaining same. It's slowly starting to decrease, and finally it'll come to a state of rest. Damped vibration is the type of vibration which happens when there is an external force acting on it. There's some sort of, so what is the reason that it's coming to a state of rest? Because there is air around it, because the friction that is produced between the bob of the pendulum and the air particles, it is starting to lose the energy in the form of heat because of friction, and it slowly comes to a state of rest. This type of vibration is what is called as damped vibration. This is something that you see every single day, because on earth you cannot, there's no vacuum, everywhere. Like you can't just create a vacuum field. You need, I mean, you can create one, but that requires a lot of care, a lot of, machineries and all that. But damped vibration is something that is very, very common because of the fact that there's air particles everywhere. So here the periodic vibration of the body is decreasing its amplitude because of the resistive force. That type of vibration is what is called as damped vibration. Now another example is basically when you're, I'm pretty sure you've all, been on a swing before. Now in a swing also, you see that sometimes when you touch the ground, you slow down. You slow down when you touch the ground. So again, someone has to push you from behind, or you have to, push yourself to the front. So you have to basically give more force to it so that you don't come to a state of rest. This type of vibration is what is called as damped. You look at that. So he's slowing down when he touches the water, so that this type of vibration is what is called as damped vibration. Because of that resistive force, because of the air friction, because of any type of friction that is present, it slows down, or the amplitude of the vibration decreases. That type of vibration is what is called as damped vibration. Now, if you think about it, there are basically two types of forces acting on this damped vibration. There is a resistive force, that is the frictional force. Together with it, there is also restoring force. Restoring force is always present because it's always trying to bring it back to its original state. So restoring force is something that is present. Together with that, there is frictional force as well when you talk about damped vibration. Right, I hope you understand this, people. So if you draw a graph, again, a displacement time graph, this is what the graph would look like, people, because it's decreasing. The amplitude is basically decreasing, right? Yeah. It's going lower and lower and lower, finally it just vanishes, flat line. So that is what happened in the case of damped vibration. Now, again, if you want to draw it out, it'll be like this. Like it's slowly decreasing, slowly decreasing, slowly decreasing. I mean, my diagrams are bad, but yeah, you get the idea, no? It slowly decreases, 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 and finally then it stops because of the frictional force and inertia. Now, what are the major difference between natural vibration and damped vibration? This is also a 3-mark questions, has been asked several times in your board exams as well. So what exactly is this? Amplitude of vibration here remains constant because there is no frictional force acting, so it will continue to vibrate forever. In the case of this, the amplitude gradually decreases and then finally it stops. There is no loss of energy because obviously the amplitude is remaining the same, so we are assuming that there is no loss of energy happening at all. But here there is some sort of loss happening in the form of heat because of the frictional force. And here there is no other external force acting on it except the restoring force. That is the only force acting on it. Here there is some frictional force as well as restoring force as well acting on it. Apart from that, the frequency of natural vibration depends on the size and the shape of the body. Here it is, because of the fact that it is lessening, the frequency is something that is less than the natural frequency because of the frictional force. It is ready, the amplitude is actually decreasing, right? So that is the reason for it. Alright, I hope you understand this. So natural and damped. Now the last one is forced vibration. Forced. Alright, now this is very simple now. Now, for example, this is the pendulum, oscillating left to right, right. It's going all the way. Now, when it starts to slow down, if you wanted to continue to oscillate, what would you do? You'll apply a force again. It'll continue to oscillate. Again, as you see that it's decreasing, again you'll apply a force. And again, as it starts to decrease, you'll apply a force again. This is what is called as forced vibration. You are applying the force again and again so that the body continues to vibrate. That, or you're applying an external force, that is what is called as a forced vibration. Another example for this is the microphone. For example, when I am talking, the diaphragm inside the microphone starts to vibrate, and that is what produces sound. And again, if I wanted to work, I have to talk, and my, the sound from my mouth starts to vibrate. The air particles, it starts to vibrate the diaphragm, and it continues to happen as long as I'm talking. The diaphragm continues to vibrate, and you see that you are able to hear the sound. So this is what is called as forced vibration. So the vibration of the body that takes place under the influence of external force or external periodic force is what is called as forced vibration. Because as you see fit, whenever it slows down, whenever the vibration decreases, you apply force again, and it's generally periodic because again, of the resistive forces, generally it's going to be the same. Most probably it's going to be the same, but it can be different. Sometimes it is all up to your will. So it does not mean that the force always has to be periodic. Like you don't have to exert the force every 5 seconds. Sometimes you do it. Sometimes you do it at 3 seconds, sometimes at 4 seconds. It's totally up to your discretion. Yeah. So that is what is called as force vibration, people. So you once again, so you have the vibrating body. As the vibration decreases because of the external force, you apply another force because of the frictional force. Again you apply it, again you apply it, and you allow the body to vibrate again over and over again. That type of vibration is what is called as force vibration. And the thing about force vibration is that it depends on 3 different factors. Restoring force, obviously frictional force, because of which that is why we have to apply an external force, and thirdly an external periodic force as well, because all of these factors are very much important when it comes to force vibration. But the one thing that it depends on the most is the external periodic force, because that is the one factor that decides by how much is the oscillation going to happen, or how much is the body going to vibrate. Because if sometimes you might apply more force, it will oscillate more, even more further, and if you apply less force, then oscillate lesser. For example, guys, let's say if I want to draw a graph again for this one. Now the thing about this graph is, guys, this can differ because it is not something that is, you can't say that it's constant like in the case of damped or in the case of free vibration or natural vibration. Here it can be completely different. For example, let's say that the body starts to oscillate, and then it slowly starts to decrease, and then you apply a greater force again, and then again it starts to oscillate, and then it starts to decrease, and again you apply a great force. So you see this here, it all depends on what force you're putting. So here you see that the amplitude of vibration is almost the same because you're applying the same amount of force. Sometimes it can also be decreasing as well. Like I gave you the example, sometimes you apply great force, sometimes you might apply less force, because obviously we don't live in a perfect world. So let's say that if that is the case, then this is what the vibration would look like. It's decreasing, and then you apply force again, it will increase, it will start to decrease again, and then again you apply more force and it'll start to decrease again. So it'll look a little weird. So it'll look something like this. So if you want to see one more GIF, this is what it'll look like. You see this is periodic force. You see this, you see that the force as soon as it starts to decrease, again you increase, again you apply a force, and it again increases. So it continues like that. This is periodic external force. This, you see this, it keeps on increasing because you're applying more amount of force. That is what it would look like. So in the case of, when you talk about forced vibration, the graph that is there can vary depending on what is the external force applied on it. Right? I hope I did not bore you people so much, but yeah, people, that is what is the topic for today, and I hope everyone of you is understood the topic. Now again, what is the difference between natural and forced vibration? This is the major difference, guys. In natural vibration, once again, there is no resistive force acting on it. Here there is an external force, there is a resistive force, and there is an external force also acting on it. The frequency depends on the shape of the body. Here the frequency depends on the force applied. Whatever force you apply, that is what it depends on. Here the frequency remains constant. Here it keeps on changing depending on the external force, and the amplitude of vibration remains constant. Here it depends on the external force. So pretty much everything is dependent on the external force when you talk about force vibration, right, people? So that pretty much concludes the topic for today. Don't forget to like, share, and subscribe. I know a lot of Jakarts people, so do not forget to like as well. Anyways, before we get into the question and answers, because there is a lot of questions that I would like to ask you people, let me know what is the answer in the comments below. Let me know how was the session as well. Did you guys understand my explanations, and tell me how was the pendulum as well, because this is probably the best pendulum that you'll have probably seen in your life, right? So it's I think this is my left earphones or right earphone, I don't know, but yeah, you get the point, people. Anyways, before I get into the question, let me tell you one thing. If you want to join us, if you want to gain 100% knowledge, if you want to score 100% mark, there is a way to do that. All you gotta do is click on the link that is given in the description below. Join with the best of the best teachers, with the best of the best online platform that is out there. So the thing is this, people, for all of these sessions that we're going to be doing in the Vedantu platform, you have unlimited live class. You can attend how many of live classes you want, and you have the highest level of quizzes with the best of the best teachers is what you're going to be studying with. So you're going to be in safe hands. We'll be ensuring that you guys are taken care of. You'll be competing with the rest of the world to check where you're at. You're not going to be just competing with your friends within your state or within the country. You'll be competing with the entire world to check where you're really standing. And you will be getting interactive replays. So because there are sessions going on every single day, there are sessions are going on 24/7. So it's not possible for us to attend all the sessions. Even if you miss out a session, people, you can watch the interactive replay where you can take part in the quiz and get a leaderboard as well. So even for the replay, you can take part in the quiz, and it will also show you the leaderboard where you would have been if in case you had attended the session as well. And people, you have the complete option to download all the premium content, everything that we teach over here, and all the gifs and everything can be downloaded, and you guys can refer to it how many number of times you want. You get the handwritten note of every single master teacher, so everything that is written can be downloaded and can be read over and over again. Apart from that, people, you have in-class doubt solving. This is like probably the best feature of them all, because whatever doubts you have will be cleared inside the class with the help of the master teacher and the class teacher as well. So both of us will be there to help you clear your doubts. The class teacher's job is to make sure that your doubts are cleared inside the class, so everything would be done inside the class itself. And guys, this is the best part. You get 5,000 plus micro courses all for free if you enroll into the pro subscription course, and free crash courses with all your NDSC preparation. Everything would be covered in that pro subscription course. The link is given in the description below. The coupon code if you want to avail is basically AME Pro. That is my coupon code. Enter the coupon code to avail the amazing discounts as well, people. So let me just quickly tell you what it is. If you enroll into the 1 month program, including the coupon code, if you enter the coupon code AME Pro, you get a discounted price of 2,159. For the 3 month subscription, it will be 5,599, and for the 6 month subscription, it will be 9,199. Again, guys, you're going to get the best of the best teachers, and in that 1 month you would have roughly attended about 200 classes, and that is a rough estimate. You would have done probably more than that itself. If you were to attend 200 classes, a minimum of 200 classes, you would have been paying about 11 rupees per session. 11 rupees, people, for your own education, for your own future. If you talk about the 3 month program, you'll be paying about roughly 9 rupees per session, and for the 6 month program, you'll be paying about 8 rupees. So you're basically paying lesser and lesser if you increase the number of subscription month. And yes, people, you'll be in safe hands, I can guarantee that. And more importantly, guys, the price of this is going to be less than what you pay for Lay's, people, because I'm pretty sure every one of you guys like munchies, and what you're going to be paying for your future is going to be less than what you pay for your munchies, right? So yeah, people, again, the link is given in the description below, and the coupon code is AME Pro. Check out the link. It's given in the description and on the pinned comment section as well. Alright, so with that said, guys, let's get into the questions now. Again, I want all of you guys to try out each and every question. Let me know in the comment section below if you guys are finding the questions hard or if you're finding it too easy. Let me know everything in the comment section below. I am taking every single, whatever free time I have, I'm trying to go through your comments as well. So let me know in the comment section below, right? So here is your question, people. The vibration of a body that takes place under the influence of an external periodic force is called as dash vibration. An external periodic force. It's there in the answer. The answer is given in the question itself. Natural, damped force, or none of these. And the answer to this question, people, force, periodic force, forced vibration, people. It's forced vibration. No doubt about it. It's going to be forced vibration, because that is what that allows the body to vibrate continuously, because of the dampening force that is there. That is a resistive force. Second question. A wire stretched between two support is plugged exactly in the middle and then released. It neglects the resistance force that is there of the medium. Is it going to be is it going to vibrate at natural frequency or damped frequency, or is it damped vibration, natural vibration, forced vibration, or none of this? You have a wire that is stretched at two, and you have fixed it to supports, and you plug it exactly in the middle. What type of vibration do you see over there? Natural, damped, forced, or none of these? And the answer, guys, 5, 4, 3, 2, 1. Forced. No, it's natural, people. Natural vibration is what you see over here, because it's, like I told you, a string. Remember, a string would vibrate at its natural frequency, right? And remember the factors that it depends on: the length, the density of the medium, the tension on the wire, and also the radius of the wire as well, or the string as well. So all of these are the factors that it depends on. Yeah, we go. Third question. This is the third question. When a body vibrates with its natural frequency, the force acting on the body is zero, proportional to its velocity, proportional to its displacement, or none of these. When a body vibrates with its natural frequency, the force acting on the body is zero, proportional to its velocity, proportional to its displacement, or none of these. And the answer to this question, people, is not zero. It is proportional to its displacement, because the initial force that you apply, obviously, what if you apply greater force, if the, like I told you, if the pendulum is in the vacuum, and the more force you apply, more will be the displacement. If you apply less force, if you apply lesser force, for example like this, it will only vibrate, the displacement will be much more lesser. So the force that you apply is proportional to the displacement. How much is the displacement? The external force is zero, but the force that you apply, that is acting on the body at the first or the initial stage, is going to be equal to the displacement of that of the particular wave or that particular body, right? So that is the answer. Is moving on to the fourth one. That is an interesting question. Moving on to the fourth one, the frequency of vibration of a stretched string can be increased by what? Increasing the tension of the string, decreasing the length of the string, increasing the length of the string, or both A and B. The answer, chat box, no, comment section. The answer to this question, people, is going to be option number D. Because if you remember the formula, it is basically F is equal to 1 by 2 L, small l, root of T by pi r square D. That is the formula. So if you remember it, it depends on the tension. So if you increase the tension, because it's directly proportional, F is directly proportional to tension, and F is also indirectly proportional to the length as well. So if you decrease the length or increase the tension, you can actually increase the vibration of the body as well, right? So you can increase the frequency of vibration. So the right answer is option number D, right, people? So that is the answer. Moving on to the fifth question. Here's another one. Which of the following is not an example of free vibration? Which of this is not an example of free vibration? If the bob of a simple pendulum is disturbed, it oscillates about its mean position. Load suspended from a spring when compressed and released oscillates about its mean position. A stretched string when plugged at the midpoint executes oscillation. Vibration of a diaphragm in a radio speaker. Which of this is not an example of natural vibration, which is nothing but a free vibration? Natural vibration and free vibration being the same thing. It's not two different, different types of vibration. It is the same thing. Natural and free mean the exact same thing. So which of this is not an example of free vibration, people? And the answer to that question in 5, 4, 3, 2, 1. Option number D. The vibration of a diaphragm is forced vibration. Remember, because again, you have to keep on applying the force so that it continues to vibrate. Because of the friction, it stops to vibrate. So you have to keep on applying the force so that it continues to vibrate. So in the case of microphone, radio speakers, all of these are forced vibration. Whereas in a pendulum, it obviously oscillates about its mean position. In the case of the spring, also it oscillates about its mean position. In the case of the string, also, if you pluck it in the middle, it starts to oscillate, right? So that is the answer. Moving on to the homework question for today, people. I hope you enjoyed today's session. This is your last question for today. Vibration in which amplitude decreases with time are called as dash. Let me know what is the answer in the chat box, people. Once again, the vibration in which amplitude decreases with time are called as dash. Let me know what is the answer in the comment section below. I hope you enjoyed today's session, people. And if you want to take part in the NTSE preparations as well, the link is right here. You can just take down this link if you want to. This link would take you through to the NTSE preparation, because you know that NTSE is right around the corner. This session is going to go until 30th of December, and you have a 90% discount on this as well. It's not going to be 9,999, but it's going to be instead 999. It's going to be super affordable for you people. And this is the NTSE preparation we're going to talk about. And if we talk about the NTSE mock test paper, again you get a 90% discount. It's not going to be 999, it's going to be just 99 rupees for the mock test paper as well. The link is right there for your NTSE preparation. Again, we also have the YouTube channel vdnt.in/VOS is the NTSE for Vedantu Olympiad School, that is that. So you can take part of that. It's completely free. Subscribe to the channel and also learn from the best of the best teachers with experiences more than 10, 15 years of experience. The teachers with such amazing experience are going to be there on that particular channel. So once again, thank you guys. The link is given in the description below for the Vedantu course. Do not miss out on the micro courses, people, because you're getting it for free, and more important, there's only limited seats to that. So do not miss out on this opportunity. The coupon code is AME Pro. Thank you for joining. See you in the next one. Subscribe to the channel. Hit that bell icon, people. Let it ganti baja do. Yeah. So yes, thank you for joining. See you in the next one. Take care of yourself. Stay safe. This is Anoop signing off the day. Have a great evening, guys. Bye.